The following program is brought to you by Element 14, the electronics community where you can connect and collaborate with top engineers from around the world. Join now at element14.com/presents.
Welcome back to this festive edition of Element 14 Presents. I'm David and you're here today to join me as I try and improve this rather lackluster Christmas train.
Amazing hacks. Inspired designs. Each week, Element 14 Presents brings you innovative projects using electronics, engineering, and more.
Now, I should explain that we bought this a good few years ago and we didn't spend a lot of money on it, if you know what I mean. It does work, but it's not nice. You obviously have the locomotive and a series of track. Now the biggest problem I have is that the electronics inside, and I can only assume that there is a very basic ASIC inside, as soon as you press the on switch on, it starts going full whack. And when you're trying to balance that on a section of this track and you're trying to flick that switch, it has a tendency to do exactly what it just did there, where the front jumps up in the air and it invariably jumps off the track, and then you have to catch it, stop it, and then start it again, and it's a bit of a trick, and it's tough for me. So imagine what this is like for my son, who is not very old. We'd like to improve this and also see if we can do something a bit more interesting with something a little less offensive with the sounds, a bit more interesting with the lighting, a bit more control over the speed of the motor. And finally, I have this horrible little notion that if we put a Hall effect sensor in the bottom of this, we can set up one of these points and with a magnet on it and have it stopping at a recurring station kind of thing. And it'll just be a bit more fun, and maybe we can introduce some wireless Bluetooth or web-based control for this. But before we can do any of that, we've got to find out what's inside and what we're dealing with to find out what we're going to need to be able to accomplish this. So, as I do with pretty much everything, let's tear this apart and see what's inside. I can't really remember what batteries are inside this. Looks like 4 AA's to me, and I imagine everything runs at 6 volts, including the motor. Probably just get direct feed onto it. I think a battery carrier actually. So there's a reduction gearbox. It's actually worm driven off of the motor. So the motor is vertically mounted in there. There we go, a couple of axles out already. Ooh, gearbox comes out nearly, but does give us clear access to a couple more screws. There we go, not a lot to this at all. So let's free that. Yeah, excellent. So in trying to pull the LED or lamp or whatever that is out, I've just pulled the leads off the back of it. So that's just, it's all hot glued in. A nice lump of lead as a weight to try and keep it on the track. Actually not a horrendous speaker. With contacts from the battery removed, there you go, all the electronics just slip right out. So we've got the nice little battery holder that actually holds 4 AA's and just gives the 6 volts into the train. Actually a nice little battery holder, so we'll definitely be keeping that. Also got the gearbox. You can just see down inside here, it's actually a worm drive, so gives nice high torque output from the motor, which is just in here. Already got a cap on it just to prevent any inrush current. Yeah, because it's a worm drive, it can't be back driven, which doesn't help, doesn't hinder. I'm not too worried about it. This little ASIC is fascinating. Great little glop top. As I say, 3 unused terminals on here. But yeah, that's got no hackability in there at all. And on the back, we just got this one weird part number, which we might be able to look up. Probably not, but c'est la vie. And on the other side here, she's got a decent speaker that's already picking up all the screws. And again, I can't see any reason to replace that, so we'll make use of that again. It's decent magnet actually. Okay, so I've been on a bit of a hunt around and I think I've found and pulled together all the bits I need for this project. So I've managed to find a Raspberry Pi Zero W, which for an existing project is already half populated with a female header, Now, that's a good thing. I kind of like female headers on there. It makes for easy prototyping. I've also got a buck boost on the board, which I think I'm going to reuse to get the 6V to 5V for the Raspberry Pi. So that'll come in handy. I've also found, got some perf board and various pins and headers. Again, that's going to be very, very handy. I'd kind of like to make this into like almost like a hat kind of form factor, so I can just push this into the Raspberry Pi and hopefully it should be transferable to anything. I've got a load of passives to make up various bits of circuitry. Most of that goes towards making high and low pass filters for the audio output, because the Raspberry Pi Zero doesn't actually have an audio output of its own, so you're going to have to make one using GPIO. We've also got this DF Robot Hall effect sensor. Lovely little thing, 3 to 5V input, and you can have it digital or analog out. For what we're doing, we only need digital output, which is fine. We can just set this up and wire it to a GPIO. And the last piece of the puzzle is a Texas Instruments an L2930DNE motor controller, so I can give this some line voltage and also some control voltage, and we can control the motor nicely using this. As I say, we're going to lay this all out on the perf board. Now, I have done some planning. If you ever needed an insight into how my mind works, I started by laying out individually the circuits that I actually need to make this work. Nothing too complicated there. So you've got the motor controller here. It's a 16-pin DIP package. You've got the 3 pins for the Hall effect sensor and the GPIO 13 and ground, and all the passives making up the filters for the audio. So I then took that and laid it out on a grid. My first attempt was horrific. So I tried again, and I've got the layout, and it's going to be quite narrow. I'm going to lay the DIP package of the motor controller perpendicular to the GPIO, so hopefully that will give me a nice neat package with a bit of space to play with in the middle, because I want output pins so I can actually plug stuff in and out of this. But I guess the only other thing to do is start soldering it. Please don't laugh at my soldering skills, they aren't the best, but I'm always willing to improve, and you learn by practice, so away I go. That's about the neatest soldering I've done in about 15 years. Okay, so that's the header soldered on. Now all I've got to do is transfer all of my carefully planned out wiring onto the board. Okay, I'm actually going to solder that in place, since why not? I think that's kind of the starting point for a lot of stuff. So I'm going to do that next. Okay, so while I'm here, the middle 2 legs on each side of this are actually a ground plane as well as used for heat dissipation. So I'm just going to kind of flood these out. That way, if there is any heat to speak of, it's got somewhere to go. So it may not be pretty, but it's what I've got available to me. It should work. Incidentally, I've got this awesome little Element 14 GPIO guide, and actually I can line the holes up with this, or I can flip it over, and that's representative of each pin. Very handy little toy. Okay, the next step I'm doing is getting my passives out and positioning them where I want them on the PCB or on the perf board, and then I will solder as many directly up as I can, only using hookup wire where I need to, basically. Okay, here is my completed circuit. So on the bottom we have the 40-pin GPIO interface. I put male pins on here, so this is in theory a hat, which I'm kind of proud of. I guess I could have put the female on here, but I prefer the female on there. It means when you're testing you can just plonk an LED straight into one of the ports, obviously with a resistor. I have a handful of made up just with little male jacks, so I can just plug them in for testing. It's quite handy. And on the bottom we also have these angled outlet pins, which are for, starting from this side, you can see the motor. You've got 4 pins for the RGB LED, 3 for the output and 1 for ground. The next 2 are the sound, and then the last 3 are for the Hall effect sensor. So everything connects underneath at an angle, all the IC on top, and you'll probably notice these nice 2 big wires here. Now these run back to the buck boost, but the input side of the buck boost. So you follow back from there and you've got the connections to the battery terminal. This means that the IC for the motor control doesn't actually draw current from the Raspberry Pi. All the power for the motor driving actually comes straight off the battery, so you don't overload the Raspberry Pi. Perfect. It does actually draw 5 volts, but I think that's just to actually energize the internal logic. Yeah, I appreciate that there are people that could have done a better job than this than me, but I'm happy with it. Do you know what? I'm pleased with the result, and I could do it again and probably do it better, but I'm not disappointed with the result. It's as good as my ability will allow, so I'm pleased with it, and if it works, I'm golden.
Hello, I'm James from Workbench Wednesdays, a show about the stuff found on your electronics workbench. Look for new episodes on, well, Wednesdays. You can connect with me over on the Element 14 community. I look forward to seeing you. For now, it is time to get back to watching this week's project video.
Right, this script I've written to run the whole train, right, Python is not my natural language. It probably make a lot more sense to you if you read each of the individual scripts on their own first, get your head around those before we start looking at the main one. And there are definitely people that can make this script a whole load more efficient and more dynamic than I have. I'm just pleased I made it work. But anyway, to start with, the first thing we do is include a few libraries. Obviously you need a GPIO library for the control, hopefully that's quite obvious. The next thing is import sleep, which we use to build delays and sleeps and things like that. And we also use the mixer library from Pygame. Now I've used that because it's included with pretty much every Raspberry Pi off the bat. You don't need to install it, and I use that for playing back audio. It might not be the clearest way, but I figured it was available to everybody on a Pi. Okay, we then have a couple of functions which I'm going to skip over for now. And then we go through declaring a load of variables. Now a lot of these are just defining which pins I've used for what thing. So at the bottom you can make out the red, green and blue LEDs, and at the top this is the input pin for the Hall effect sensor, which is number 26. And these three here are associated with the motor control. So that's IN1, IN2 and EN1. They're the names of the pins actually on the motor controller IC. So I've tried to make it make a bit more sense that way. Technically they're all outputs. Two of those define the direction of the motor, and the third one actually is the PWM pin, PWM18. So there are a few other variables I've included here to sort of define how the train runs. The first one is train state, which has 4 states, which we iterate through, and depending on what state it is, it does a different thing. Number of laps, so every time the Hall effect sensor is triggered, it counts an additional lap. Train station, that is how many laps I would like it to do before it stops at a station. There won't be a station, but you know what I mean. Train wait is how many seconds I would like the train to wait at the station before it starts up again. And the last one is light state 1. That's just an initiation state, so it starts at 1 and it will iterate through depending on the colour. Okay, so the next line is mixer init, which is just preparing the software to play sound. Then we go through a whole load of GPIO setup with one input, several outputs, and of course we then have the pulse width modulation down at the bottom here on our GPIO pin. So all of this just sets up all the GPIO pins doing their appropriate thing. So this line then adds the event detection. So it doesn't matter where in the code this is executing. Once this event listener is in place, the Hall effect sensor will do its job and call its function. So it doesn't matter if it's somewhere else in a loop. We're looking for a rising edge on the detection. We don't need to wait for it to be at a position where we can read its state as high or low. So what that then does is trigger the function at the top, which we skipped over to start with. Now it doesn't look like much, this function here. Now all that does is import a couple of settings, looks at how many laps the train has already done. If it's less than however many laps we've said we want it to do, then it will put the train in state 3, which is our hooting state, whereas it just continues around but hoots as it goes. Otherwise it says train state 4, which is going to stop for a station. So this loop is where all the good stuff, all the action actually happens. So while true, sleep half a second. We don't want this code running sort of wild. If it goes too fast, it will just overheat and make the Pi run hot and probably drain the batteries super quick too. So we then call a function called LED color change. Now that function basically iterates through 4 states, and every time it goes in and executes a block of code to make the LED a certain color, it adds 1 to that variable. So the variable each time it executes goes 1, 2, 3, 4, 1, 2, 3, 4, and it looks for that state, and as it reaches a state, it then changes the color to suit. That's a long function, but it's pretty simple. So look for light state. If light state's 1, change the LED to green and add one to the light state. Else if the light state is 2, turn the LED red and then add one to the light stage. You get the idea. And then on the final iteration, light state equals 1, so it's just resetting it back to the 1 for future iterations. So if train state equals 1, on the console it's going to print out train starting up. It'll play a nice sound and go through that pulse width modulation duty cycle and accelerating the train. Then it sets the train state to 2, and at that point it's free to loop, just says train running on the screen. Nothing more exciting happens than that. Then you've got if train state equals 3, so that's when the Hall effect sensor is triggered. Then it plays a hoot sound as it goes past, and you have to wait 3 seconds for that sound to play out in full. You have to wait for the sound to finish, it won't wait for you. Then set the train state back to normal running. Then on the 3rd time it's been ground, in my case with my variables I've set up, then we slow the train down, play an extra sound, wait for the train to wait its full time, reset the states, and go again. And in theory, that will go a loop and loop and loop and loop. So it'll go start up, once round hoot, twice round hoot, 3 times stop, wait 20 seconds, do it again. Keeps doing that until the batteries are flat, in theory. Now, I've deliberately kept the code and the execution of what it actually does kind of simple because it's something I'd kind of like to play with, and my son will probably have an input and it will become a bit of an activity at Christmas when he's not at school and stuff, and we can just play with it and see what fun things we can make the train do. At least that's the idea. He'll probably play with it once and get very bored with it. That's what the code does. So let's run this script. Hopefully we'll start with the sound. Excellent. LED should start cycling colours and the motor running. Perfect. So on the screen we've got train running, train running, train running. I'm going to wave my Hall effect sensor near it. Hooting. Perfect. Running, running, running. Hall effect sensor. Oh, too much. Hooting. Running, running, running. Hall effect. Train stopping. Perfect. Great. Well, I'm happy with that. The only drawback now, once this starts up at least, got to wait 20 seconds, is that I've got to figure out how I'm going to fit all of this back in the body of that train. Right, everybody. Fingers crossed. What more could you want? A train that's Wi-Fi controllable-ish. Well, this is not a flawless train, but I'm pleased with the outcome. There's a few things I would change. I've maybe used some smaller gauge wire on some of the items. Definitely want to upgrade the power supply from AA's to rechargeable, probably. Something like a charge boost controller instead of a buck boost. But yeah, all in all, I think this is going to be a really fun Christmas evening, Christmas afternoon activity that I can do with my family. And yeah, I hope you've enjoyed following along, and whatever you celebrate, happy holidays.